Hi guys, I hope you are doing well. So today we are going to do the concept of laws of exponents, which will prove to be a strong basis for you to be solving any kind of an exponential equations just like a pro. Okay, so concentrate now guys, and we'll get into the details of about 7 laws that today I propose to work on. All right. Now, a to the power m. Let me just straighten up. A to the power m multiplied by, say, a to the power n. It is equal to m n being the exponent for a. All right, guys. So, if you can just see the details, we have the common basis. Then and only then we can add up the exponents. All right, guys. For example, if we were given x to the power, say 4, multiplied by x to the power 5, we can very easily write x to the power 4 plus 5, which is equal to x to the power 9. All right, guys. Now, this is applicable to even certain powers, say p to the power minus 5 multiplied by p to the power, say 2. What do you do in this case? Obviously, we again follow the law very religiously, right? So, minus 5 plus 2, which is equal to minus 3. Correct? No worries at all. Even if there is a minus, we are adding up as per the integral rules. Correct? What if there were two negatives? Minus 2 multiplied by, say, minus 3. Okay? Powers. I'm referring to P being the basis. Correct? In that case, minus 2 plus, okay, minus 3, which will be equal to minus 2 plus minus minus 3 equals to p to the power minus 5. Correct, guys? As simple as that. So this rule is very important for you to understand and settle with. Now we are going to number 2 law, which is a to the power m divided by a to the power n. Remember, in both the cases we have the basis same. These are the below ones are called the bases, and these are the powers exponents. In that case, we bring this to the numerator, okay, and write m minus n. Correct? Up. What next? The next is, I'll give you examples. Say if you have x to the power 5 over x to the power 4. We write 5 minus 4, that is x. Correct? X to the power 1 is written as x. If x to the power, say, 5 over x to the power minus 4, then what? Then what? Nothing. Minus will be over here. We'll bring minus 4 to the top, and we'll have minus minus plus. That is 5 plus 4 equals to x to the power 9. Got it? As simple as that, guys. Okay, now moving on to the next one, third one. What does this mean? Let me just make it straight. So this is a to the power m, and outside there is a bracket which also holds another power. So in that case, this is going to multiply with that, and we'll have collectively a product of these two powers. Okay, giving you example, say if we have x to the power, say 5 here, and outside, say 6, which means what? X to the power 30. If x to the power 5 having a power of minus 8 outside, in that case, obviously it will be minus 40, because minus 8 multiplied by 5 is 40, and minus plus minus. All right, guys. Now I hope it is clear. Now, what about this? Okay, some more coming up. So please stick around. So here we have a to the power n. All right. And then we have below b to the power n. In this case, what are we to unfold now? That we see there is similarity in the powers. So can we not write a upon b and together give them their powers? Because this is, okay, split. Here it is united, correct? So we have this. In an example, supposing, you have, say, 2 and 3 here, both having the same power. Then 2 upon 3 written together to the power 3. Got it? Which means you multiply 3 times and that's another story. Okay, and then you get the answer. In this case, if I were to do 2 to the power 3, 3 times, okay, so we'll have 8 over 27, guys, like that. Okay, so as simple as that. Now, this is very interesting. Okay, so what does this hold for you? So they are saying a having a power of 0, okay, means 1. Now, this is very mystical. Okay, isn't it? Why a to the power 0 is equal to 1? There must be question in your mind. Why should it be equal to 1? Why not 0? What do you mean by this? Let me just explain you. Okay, giving a good example. Say P having a power of 3 and the very same has a power of, okay, 3 but sitting below as the denominator. P means P into P into P and P into P into P. Correct? This gets cancelled. So you have a 1, 1, 1, 1, 1, 1. So you get 1 upon 1, which is equal to 1. But if I were to follow this rule, would I not write this? 3 minus 3, which is P to the power 0, which will be equal to 1. And so the case is closed. I know that a to the power 0 will always give me a 1. And why? Because P into P into P, okay, over P into P into P, okay, will give me on cancellation 1. So now you see the logic behind anything to the power 0 giving me a 1. Correct, guys? So remember, a to the power 0 or p to the power 0, x, y, z, anything to the power 0 will fetch me a 1 as answer. Okay, so go dash, okay, blindly towards it. Now, what is this base all about? Well, this is having a power of minus m. A has a power of minus m. And they are saying that it is equal to the reciprocal. Okay? Say this. Okay? Or you can say this. M, any power, okay, goes by it, will still be as 1. All right. So whenever there is a negative power, say if I give you an example, x to the power minus 2. Okay. It means what? X to the power 2. This will become positive. There are questions, guys, when they will ask you to give answers in a positive value of, okay, exponent. In that case, you would know that to do away with this minus, you have to take it to the bottom and make it positive, which means I can write this as this also. Correct? Understood? Very clear? Okay. So this is what, and how do you get a minus is also something to think about. When do you get a minus? I'll give you an example of that. Say if you were to have, okay, say p to the power of 3 over p to the power of 5. So as per, okay, this rule, when you bring something from the bottom, okay, so it is to be minused, okay. So p to the power 3 minus 5, this will be equal to, okay, p to the power minus 2. Okay, let me write it clearly, p to the power minus 2. Got it, guys? So, can you see? This is how you get a minus also in the powers. All right, when the power in the denominator is larger than the one on the top in the numerator. Last one, but not the least, this is also very important. And how do you go about it? Okay, let me explain you. Now, as you can see, okay, we have a, okay, to the power 1 by, say, n in this case. This means what? They are saying, if I have to unfold this, okay, it means that a to the power, okay, nth root, remember. So if I write, say 5, okay, to the power, okay, say 1 by 3. What does it mean? It means that 5, okay, and 3 here. It has a cube root, 5 cube root, okay? Got it? So basically what I'm trying to say is that your n will be deciding which root it is. See which root it is. Understood? For example, if it is 1 by 3, like 1 by n, this will tell you which root it is. If I were to elaborate this, supposing you had another question, say 125 having a, okay, cube root, okay, of this, you call it a power of 1/3. Can we write 125 to the power 3, which means what? 5 cube to the power 3. Answer would be 5. Understood? So it's as simple as that. Okay, guys? So guys, these are a few important laws of exponents which you can use it okay, for solving problems based on exponents, and they are pretty much handy as they will come to your help and rescue every now and then. So these are the very basics that you have to have a knowledge about, and I hope it is clear. In case you haven't understood or something that I need to, okay, once again reinforce, okay, so please let me know in the comment section, and that is what, okay, I can say, because it's highly necessary that you graze over them and try to understand every bit of them. Okay, guys, so thank you so much for watching, and if you like the video, do share with your friends. Thank you so much, guys. Bye bye.